Okay, so somebody was asking a question. Whether pension payment to retirees. Yes, an example of perpetuity. Okay, once we receive cash flow forever. Okay, once we receive cash flows forever. Once we receive cash flows forever, what I want you to know is that it's an example of a perpetuity, all right? Then again, sometimes for perpetuity, it grows. So there are some perpetuities that it grows. So sometimes you can be receiving a fixed amount, but that amount too will be growing, okay, at a regular interval. And that is what we call a growing perpetuity. Now, let's get into the basic formulas. So I told you that the only difference between receiving money now and receiving money later is simply because of the interest, because we have to pay interest as a compensation for what? The risk, the time, and even inflation. But when it comes to interest, there are two main types of interest. We have something we call simple interest, and then we have compound interest. So there are two types of interest. We have simple interest, and then we have compound interest. Okay, simple interest and then compound interest. Now, when it comes to simple interest is a form of interest that doesn't attract interest. And let me explain. So simple interest is a form of interest that doesn't attract interest. So let's say you invest. So let's get this example. You invest 5,000 cedis at, let's say, 5% interest rate. Okay, 5,000 cedis at 5% interest rate for 3 years. Now, what is the simple interest on it? Now, I've told you that simple interest does not attract interest. I mean, the interest does not attract interest. So let's say year one, okay, if you are investing 5,000 cedis, you just multiply 5,000 by 5%. So 5,000 by 5%. And that is 250 Ghana cedis as an interest. The second year, you multiply 5,000 by another 5%. That's also 250 cedis. The third year, you multiply 5,000 by 5%. That's another 250 cedis. Now, This simply means that, you see, this one, there is nothing like rollover, okay? The interest is not attracting interest. There is nothing like rollover. If there was a rollover, we would have added this 250 to the 5,000 so that the second year, it will be 5,250 times 5%. Please remember 5% is 0.05, as in 5 over 100, okay? Yeah, so it means that every year we are going to receive an interest of 250 Ghana cedis. And that is what we call simple interest. So simple interest, there is nothing like rollover. Interest does not attract further interest. It doesn't. Then ask yourself, what if it was compound interest? What if it was compound interest? Now, for compound interest, the interest attracts interest again. That is compound interest. The interest attracts interest again. That is compound interest. Interest attracts interest again. That is compound interest, okay? Interest attracts interest again. How does that happen? Now let's watch it carefully. So year one, it will be 5,000 times 0.05. That is 250, all right? But then the amount at the end of year one will be equal to 5,000 plus the 250, and that is what? 5,250. So year two, the principal amount of 5,000 and the interest of 250 together, the two of them together will also attract interest again. So that's why we are saying that for compound interest, interest attracts further interest. So it will be 5,250 times 5%. And please, those of you who don't have calculator, please try and get some. You can't be doing MBA accounting or finance without this thing, calculator. So here the interest will be 262.5. And the total amount for year two will be 5250 plus 262.5. So 5250 plus 262.5. So everything will be 5775. Everything will be 5775. Okay, everything will be 5775. And when it comes to year three, when it comes to year three, remember at the end of year two, we have a total. So here is that we are doing rollover. That's what some of you call it. You call it rollover. So year three is going to be 5775 times the same 5%. So 5775 times 5% is 288.75. So the total amount at the end of year three will be 5775 times, plus the 288.75. So 288.75 plus 5775. The answer will be 6063.75. So that's the answer. So that's the answer. So that is the concept of compound interest, all right? Now, let me show you something interesting here. Let me show you something interesting. The first year, okay, was 5,000 plus 5% of what? 5,000. Because 5% of 5,000 was 250. So 5,000 plus 250 is like saying 5,000 plus 5% of 5,000. That's the implication, all right? That's for the first year. Okay. Now, I know some of us, it's been a while that we did some of these interesting mathematics, but it's very simple. Now, if you want to factorize 5,000 out, I'm still going, so I've started again with year one. If you want to factorize 5,000 out, it will be 5,000 into bracket 1 plus 0.05. This is how we factorize, because 5,000 times 1 is 5,000 plus 5,000 times 0.05 is like 0.05 times 5,000. So this thing here is what I've rewritten as this, okay? It's what I've rewritten as this, all right? That's what I've rewritten as this. Now year two, okay? It will be 5,000 into bracket 1 plus 0.05. Remember, 5,000 into bracket 1 plus 0.05 is actually, if you have calculator, when you punch this thing here, you get a 5250, like what we had for the first year. You get 5250, okay? You get 5250. This thing again is also going to grow again by 5%. So I'm going to multiply this thing again by 1 plus 0.05. So by 1 plus 0.05. And in year 3, this whole thing again is going to grow by 5% to 5,000 into bracket 1 plus 0.05, 1 plus 0.05, 1 plus 0.05. Because this whole thing will grow again. So when you factorize, it looks like this. So by year 3, remember in mathematics, A times A is A squared, or A times A times A is what? AQ, or A times A times A times A is what? A raised to the power 4 in mathematics. So here, this thing times this times this. It's like saying 5,000 into brackets 1 plus 0.05 raised to the power 3. Okay, raised to the power 3. Those of you who have calculator, you can just punch this. 5,000, 1 plus 0, so 1 plus 0.05, you get 1.05, okay? Then raised to the power 3. For those of you who have calculator, you can just punch 1.05 raised to the power 3. I want somebody in calculator to type in the comment section, just to be sure you are following what we are doing. Just punch your calculator, 1.05 raised to the power 3. I want somebody to type in the comment section. (1.05 raised to the power 3. Okay, Godwin, you want to speak rather? Okay, I'm coming. Okay, Godwin. Oh, Godwin, you have a question. I'm asking you to unmute, so you get like your machine will ask you to unmute, so do that.
Hello, I said I have the 125.
What did you get?
5788.125.
How are you sure? 1.05 raised to the power 3.
Yes.
What I'm also having here is different. I had 1.15. No, just this part here, just here. 1.05 raised to the power 3.
Times 5,000, you get 5788.125.
No, I'm not saying multiply by 5,000 yet. I just want.
Sorry.
So you get something like 1.1576. Okay. Good. Now, yes, I think we've had a lot of comments from the comment section. Okay. Good. Now, yes, good. Okay. So 5,000, just a moment, 5,000 times 0.05 was 250, okay? So plus 5. I think I punched something wrongly. 5250 plus 262.5. I think here I punched it wrongly here. This figure is not correct. 5250 plus this. I think I punched it wrongly. It's supposed to be 5512.5. So I think I punched it wrongly. So please forgive me for that. So here it is 5512.5 times 0.05. That is 275.625. And then so this is 5512.5 plus 275.625. You get 5788.125. Okay, I did it wrongly. Forgive me for that. Okay, so now let's come back here. The other approach that we are doing. So 5,000 times 1.1576, you get the same answer, approximately 5788. Here we've rounded it. That's why it's like this. Now, it means that when you are being asked to find future value of something, you don't need to do it one by one. You can just use this formula. Now, what is this formula? Look at the formula carefully. 3 represents the number of years, okay? 3, it represents the number of years. 5% represents the interest rate. And then 5,000 is the current, like the current amount you are using, okay? So when it comes to compound interest, it leads us to the following formula that future value of an amount is equal to the present value, which is the 5,000, into brackets 1 plus the interest rate, okay, raised to the power the number of years. That's all. So from this thing here, we can conclude that future value is equal to present value into brackets 1 plus r raised to the power what? N. So formula 1. And please, let me show you something about financial management. I mean, I've been a student before, like some years ago. When I'm writing financial management formulas, I do it like how I'm doing it now. I write future value is equal to present value into bracket 1 plus r raised to the power n. And I draw a box around it so that when I pick my notes, I know that this thing is a key formula. Some of you, the way you write notes, when you are reading your notes yourself, you can't even follow. So write it this way so that we know that it's a key formula. Okay. So where PV is what? Present value. N is the number of years or time period. FV is future value. And then one is something constant in the formula. Okay, something constant in the formula. So let's write these formulas down. Okay. Oh, somebody is saying I can't see your screen. Please, is it like that with everybody? If any other person can see my white screen, just say I can see. Okay. Because I think everybody can see. Maybe the person is because of his network. Okay, somebody said he can see. So I think maybe it's because of the person's network. So the person who said he cannot see, just leave the meeting and join back again. Okay. You can join. I've not restricted the meeting. So leave the meeting and then join back again. All right. Okay. Good. So now let's come back to our slides. Good. So for a lump sum, so we are now beginning the formulas. For a lump sum or a one-time payment, okay? Because the example I was showing you, it was a one-time payment and you left it to roll over. It's not like every year you yourself you're adding money to it. It's a one-time payment. You paid 5,000 and you allow the thing to roll over itself. So it's a lump sum payment or a one-time payment. So for a lump sum or a one-time payment, as you can see, so here for a lump sum. Okay, somebody's asking, does it mean that future value is the same as compound interest? No. No. If you want to know the compound interest here, okay, the compound interest will be 5788 minus the original 5,000 invested. The 788 alone will be the interest on the 5,000. So that's the compound interest. So future value is not the same as compound interest. Future value is not the same as compound interest. Okay. Now, so for a lump sum, future value is equal to present value into bracket 1 plus r raised to the power n. And again, present value itself is also equal to future value divided by 1 plus r raised to the power n. This is simple mathematics. Let's say we have future value is equal to present value into bracket 1 plus r raised to the power n. We divide both sides by 1 plus r raised to the power n, 1 plus r raised to the power n. Okay. This and this can cancel. Then we have this. So if you make present value the subject, it's equal to future value over what? 1 plus Rn. Okay, if you make present value the subject. Now, the tables I sent through your course reps, the tables I sent, okay? We can read the table to get the answer easily. But before that, we need to break this formula down, this particular formula. Now, this formula, okay, this aspect of the formula, this one. Remember, present value was 5,000, future value was 5,788. So this formula, this aspect of the formula is the factor that we use to compound the present value to the future value. So this factor is called compounding factor. Or we also call it future value interest factor. Okay, future value interest factor. Because that's the factor we used to compound. So it has two names. Even the table I sent to you, the table itself, the table calls it, the table I sent you, the table calls it future value interest factor. Now, when it comes to the present value formula, we can rewrite, so mathematically, we can rewrite this formula as present value. So watch the mathematics. Mathematically, we can rewrite this formula as present value is equal to future value times 1/1 plus r raised to the power n. We can write this formula as this. Okay, when you write a times 1/b, it's like saying a over b. It will come and lie on top. Okay, so when I multiply this by this, the future value here will come and lie on top, and then we have this same formula like this. All right, good. So whenever you are changing present value, whenever we are changing future value back to present value, we say we are discounting it. When you are sending future value back to present value, we say we are what? Discounting it. When you are sending present value to future, we say we are compounding it. Okay. So this factor here, this one, is called discounting factor. Or some books call it present value interest factor. Present value interest factor. So the factor is called discounting factor, or another name is what? Present value interest factor. Present value interest factor. Present value interest factor. Present value interest factor. So technically, for a lump sum, we can say future value is equal to present value times future value interest factor. That's all, like this. So this thing here is the future value interest factor. So this is it. And for present value, we can say future value times present value interest factor. It is not divided by, because here is future value times the factor. Okay. Yes. So present value is also equal to future value times present value interest factor. So we can rewrite this formula 1 and formula 2. We can rewrite them as this. And in exams, any of them you write, you are not wrong. None of them is wrong. Okay. Like whether you write them this way or the other way, nobody has a problem with any of them. Okay. Okay. Good. Now, let's go back to our slides. So let's take this example. Listen to the question carefully. How much will 1,000 cedis be worth in 3 years' time when interest rate is what? 15.6%. How much will 1,000 cedis be worth? So we are looking for the future value of the 1,000 cedis. How much will it be worth in 3 years' time? How much will it be worth in 3 years' time? So we are looking for what? The future value of 1,000. So what's the formula? The formula is simply future value is equal to what? Present value into bracket 1 plus r raised to the power n. So the present value is 1,000. 1 plus, now 15.6% is 15.6 divided by 100. So that is 0.156. Okay. Then the number of years is what? 3. So n is 3. For me, I always want us to punch the factor before you multiply by the present value. Okay, that's me. But then, I mean, you can just punch everything straight forward. So 1 plus, this is 1.156 raised to the power 3. And 1.156 raised to the power 3. So we will have, yes. So we will have 1,000 times 1.5448. Oh. Why is everything gone? Okay, so you have 5,000 times 1.15, sorry, 1.5448. 1.5448 times 5,000. Oh, this is 1,000, sorry. Am I writing 5,000? So times 1,000, sorry about that. So the final answer will be 1544.8. That will be the final answer. So the slides, the answer is even here. But for me, I always want us to work this part. And then you multiply that part by the 1,000. Okay. I always want us to work that part. But you can punch everything straight forward. If you punch it straight forward, you are not wrong in any case. Okay. Question 2. You have been promised 4,000 some 4 years from today. So listen to the question. We have been promised 4,000 some 4 years from today. So we are talking about future value. Like the 4,000 is a future value. Because we have been promised 4,000 some 4 years from today. So in 4 years' time, they'll give you 4,000. Assuming the banks are currently paying 15% on savings, what is the value of the promised 4,000 today? So that 4,000 in future, what is its value today? So we are looking for present value. All right. So remember, the future value is 4,000. The interest rate is what? 15%. And then it is the number of years is 4. So one of the things you can do for yourself, you can write them down. So future value, 4,000. Interest rate, 15%. Number of years, 4. Number of years, 4. Good. So remember, present value is equal to 4,000 times 1/1 plus 15%. So 1 plus 0.15 raised to the power 4. Let me write it in a way we can understand. So present value is equal to future value over 1 plus r raised to the power n, okay? And I'm saying that it can be future value times 1/1 plus r raised to the power n. So here we have 4,000 times 1/1 plus 0.15 raised to the power 4 years. So it is 4,000 times. Now when you punch 1/1, so it will be 1 plus 0.15 is 1.15 raised to the power 4. When you punch 1/1.15 raised to the power 4, it will be 4,000 times 0.5718. So 4,000 times 0.5718. Then the answer is 2287.2. That's the answer. 2287.2. That's the answer. It's the same as this answer. So somebody may be wondering, why am I doing the long approach? Let me show you why. Now, I sent you a table, okay? I sent you a table. I sent you a table. Now, why are the numbers dropping? People are leaving or something because you are 50, now you are 45. Anyway, now I sent you a table like this, okay? Oh. So I sent us a table. And remember, I told you that this factor here, we call it what? Present value interest factor. This factor, I told you. So you can read. So instead of doing this long approach, you can just say, okay. You can just tell yourself that, okay, now future value is 4,000, right? Let me see. I think it's for the question. Yeah, future value is 4,000. Interest rate is 15%. Number of years is 4. So you can just say present value. Oh, sorry for the red. Present value is equal to future value into bracket, present value interest factor. We are dealing with 15%, 4 years. That's what we are dealing with. So it will be 4,000 into bracket. Now we are going to read our table. Okay, so I believe all of us have the table. I believe so. So when you open the table, Look at the table here. When opening this table, there are 4 sub-tables in the table, all right? The first one is what? Future value interest factor. That's not what we are looking for. So the first one is future value interest factor. That's not what we are looking for. That's the very first one. So future value interest factor, that's not our focus. The second one is future value interest factor of annuity. We will use that one later. We'll use it later today. And even the table even gives you the form. Look at it. The table, instead of R, it says K, so 1 plus K raised to the power N. That's not what we are looking for. And the second table is not what we are looking for. So we are looking for the third one, which is on the second page, present value interest factor of annuity. This is what we are looking for. Sorry, present value interest factor. That's what we are looking for. And look at the formula, 1 over 1 plus K. For them, their K is their R. So you see they say 1 over 1 plus what? K raised to the power N, all right? Their K is their R. So we are looking for 15% 4 years. So the period is here. The period is here. This is your period. The period is here. So 15% here as against 4 years. So this is 4 years. 15% 4 years. And the factor is what? 0.5718. So 15% 4 years. 15% 4 years. The factor is 0.5718. All right, 0.5718. So 15% 4 years. The answer there is 0.5718. So I could have just said 0.5718. And I'll get my answer. And please, reading tables is allowed. So you get your final answer 2287.2. That's all. You get your present value. The reason why I didn't read for future value is that 15.6%, it cannot be found on the table. The table has 15, 16, 17. That's why for the future value, I didn't read 15.6 on it. So you have 2 options, then the choice is yours. For me, if I can read table, why should I worry myself punching? And in fact, when you are going into exam, you can send your tables there. You can print this table and send it. But the reason why we must know how to punch is that sometimes you can get a percentage that is not on the table. So you must learn how to punch. Okay, it happens. Sometimes like the future value one, 15.6% is not on the table. Okay, so that one there you have to learn how to punch. So in exams, you can send your table so far as there is no ink on it. When the invigilators see that you have written, like you have used pen to write on it, they will not let you send it. So you should think about it. For me, punching, reading tables are easier than punching.